All right, let's get started. Good morning, everyone. I'm Tom Hromatka. Paul Moore and I are the libseccomp maintainers. Paul's in the audience here if you have questions for him as well. We're going to talk today about a patch set we've proposed. This will add knowledge of a maximum kernel version to libseccomp. So in other words, if a syscall newer than the seccomp filter is invoked, what we will do. If you're not a seccomp expert, no worries. I'll give a brief overview of how it works. That should be enough to help you join in the conversation. Again, my goal with this is a discussion. This is a fairly major change to seccomp, and I really don't want to break the filter. I don't want to be back here in 2 years, lessons learned of all the CVEs I introduced. And finally, a lot of you are users of seccomp. So we're proposing a couple new seccomp filter attributes. My goal is to have these meet your needs, as well as abstract you from the inner implementation details, just in case we decide to change the way we've done it. So like I said, really brief introduction to seccomp. Seccomp is a portmanteau of secure computing with filters. So the Linux kernel has hundreds and hundreds of syscalls. Seccomp is a way for an administrator to restrict a process from invoking syscalls. So as I've listed here, you could allow a syscall, you could kill a syscall, you could send a log message to journal control, you can send a notification to a container manager, and so on. There's a lot of different actions you can take. Seccomp filters are on a per process basis. So process A may have a different seccomp filter than process B. Seccomp filters cannot be removed from a process. Once they're loaded, they're there forever. If a child is invoked, the child inherits all of the parents' filters, as well as you can add more. Finally, seccomp filters can be on arguments to a particular syscall. So if you wanted to disallow writing to file descriptor 0, have at it. If you wanted to block parameter 3 to a random syscall, you can do that. Many upstream users like to use a deny list. So I've given a really, really cheesy deny list example here. And so in a deny list, the default action is to deny the syscall. In this case, though, this particular user has chosen to allow, mainly because it fits on the screen, 3 syscalls. They're allowing exit, write, and read. So you'll see this typically in a lot of container managers. In fact, I've listed a link here to the Docker profile. They have something like 200 allowed syscalls in their filter. The nice thing is it's really obvious what you can and cannot do. New syscalls are blocked by default. I've listed that in the advantages. I would also say that's in the disadvantages. In other words, and we'll discuss this more in a bit, say openat42 is added as a syscall. Oh crud, suddenly some library needs that call is now blocked, and your container doesn't work. And again, a disadvantage is filters can get quite large. This could have adverse performance effects, but there are ways to mitigate that. The other way that some users choose to use seccomp is they do the opposite, an allow list. So the default action is to allow, and they then pick the syscalls that they think are most dangerous, or they don't want the users to invoke, or simply ones they're not invoking, and they choose to deny them somehow, excuse me. So I've picked arbitrarily 3, here again, that fit on the slide, chown, chmod, and exec. So we've decided to block those, everything else gets through. Typically, the dangerous syscall list is shorter than the not dangerous list, so filters that use an allow list are smaller. The other advantage is system upgrades rarely break, again, because new syscalls automatically are allowed. Great, they're just automatically allowed, but what if it's a dangerous one? Or what if it has a CVE against it? You now may have a hole. So that brings us to the problem statement. 10 years ago, a user requested this feature in libseccomp, and the request was simple. So say I write a filter today, June 2025, Linux kernel 6. Whatever is out, and I know all the syscalls that I need to support. I know all the syscalls I want to block. I know my filter. Fast forward to 2020, 3 months later, Their filter's in production, everything's working great. The latest, greatest Linux kernel comes out and it has a new syscall in it. Oh crud. No matter which path you chose, allow or deny, an explicit path is going to be taken and it may not be the one you want. So their request was simple. If there's a new syscall that I don't know about in my filter, I would like to be able to explicitly specify a separate action beyond what I currently know with what I've chosen to allow and deny. I've listed 3 issues here. If you go look at these issues upstream, you'll see that these fork out to tens, if not hundreds of other issues in other GitHub projects. So for example, the runc one's quite interesting. They've actually implemented their own solution, but I'd like to try to get a more generic solution for everyone. So that's where we are today. So I've put up an example here. So say you're a user. You've developed your allow list. Like I said, everything is working great. You know, it's in production, no problems. You run your update, whatever it is, DNF, apt, whatever. You run your update, and oh, things are happening. Suddenly, this brand new CVE, or this new syscall comes in, open with CVEs. I've obviously chosen a poorly named syscall here. And it's now allowed. And this has happened in the past. There were syscalls where, as soon as they were released, there were many CVEs against them. And this is allowed on your system. So what do? You have an allow list, so you have a choice. I mean, you can continue to run it, you now have a security hole, or what you'll see some users do is they won't update. Okay, so they protected themselves from this, but they're sitting there on stale kernels, on stale user space. Neither is particularly attractive. So how do we solve this? So I've intentionally abstracted the inner details. They're slightly more complex, but the goal is the user can invoke 2 new libseccomp filter attributes. And they specify 2 things. Number 1, the newest kernel that they supported. So in other words, the kernel that they designed their filter against. 6.15, 5. Something old, whatever you want. In fact, I've added logic to go all the way back to 3.0. Thank you, old distros out there. So they can specify what they support, and then anything newer than that, they can also then specify what action to take. So typically, if a syscall is unknown, you can return like enosys, and then user space tools will go, oh, I don't know about this, and I'll fall back to an older. And so if they tried to invoke open at 42, it'll fall back to open at 41. But again, it's up to the user. The user can decide however they want to do it. And in fact, part of the upstream discussion has been, why do we need this at all? Why not make the default action enosys? And that would work for some people, and we can discuss that more later. But there are some users that want explicitly different actions for denied syscalls as well as 2 new syscalls. So yeah, that's the pro solution. Note that it would also work then for deny lists. I didn't explicitly list it here, but it's same idea. So advantages, as I said, works with both. One thing this should really help, the reluctance to do system upgrades should go away. I've seen this in the field where, again, they've designed their filter in such a way a system upgrade breaks them, and they're hesitant to do it, or they're very slow to do it because it takes them out of commission. That should go away. And then again, as I said, unsupported syscalls, new syscalls will fall back ideally if other user space applications are designed correctly, will fall back to old supported ones. Now, disadvantages. And this is something we should talk about. This could get to be a very large BPF filter. And the reason for that is syscalls historically have not been added sequentially. Had they been added sequentially, and if we were guaranteed that they will be added sequentially in the future, we could simply say, if it's in range 200 through 350 or whatever, these are too new for me, or I'm not going to allow them, or I'm going to do whatever the new syscall method is. Unfortunately, that hasn't happened in the past. I traded a bunch of discussions with other upstream people. The goal is to sequentially add them in the future. I am nervous to rely on that, as well as I'm not certain distros will do the same. So there's a discussion point if you're so inclined. And again, I mentioned that in the last disadvantage. Distros, and I work for a distro company, so I will take some blame here. We aren't always the best at backporting things coherently. So there could be a chance we don't backport sequential syscall numbers. So, discussion. As I mentioned earlier, if you're happy with the deny list and you're happy with the default action of eNoSys, you're probably done. You can end the discussion. You can walk out, set up your filter that way, and you don't need this. But if you want a deny list and you want separate behavior for syscalls that you knew about, whereas syscalls you didn't know about, or if you want an allow list, then this feature will be helpful for you. As I mentioned previously, how syscalls have been added and how they'll be added in the future could be problematic. So as I've implemented the code right now, I am actually going on a syscall number by number basis rather than by a range. I haven't done performance analysis, but we do have ways to mitigate this within libseccomp, including things like a binary tree, amongst others. And then questions for all of you. So a lot of you are Seccomp users. Are you using allow lists, deny lists? How are you handling system upgrades today, especially if you have a filter where an upgrade will break you? Does this proposal meet your needs, concerns, thoughts? And of course, oh, and one other thing too. So I've used a tool, upstream tool, to generate the syscall table and the versions they were added. I have a high confidence that it's correct, but I don't have a 100% confidence. So definitely assistance there would be good. Getting that table correct is critical. So that'd be one of my other areas of concern. So with that, looks like I have about 15 minutes left, and that was my goal. Questions, discussion. So Eric, can you wait for the mic, please, so I don't have to repeat? Thank you.
So pretty much from your description, I understood that you assume that the deployment goes to production like right away, like skipping all the stages. But in real world, it should not happen. We should still have pre-production stages where we can capture all these things. So basically, I would do like in pre-production, I would set just log all these things, and in production, I would set deny. So this would the process would eliminate the possible problems with upgrades, right?
I agree, except for there's always those corner cases. So I didn't touch on it. A $1 million question is, how do you generate your seccomp filter? So for example, you brought up a good point. Libseccomp allows you, and the seccomp filter itself within the kernel allows you to set logging as your particular mechanism. So much like permissive SE Linux, it doesn't block it, but it logs to journal control or syslog or whatever. What syscall was invoked and that it was invoked. But what happens in those corner cases that you didn't catch? So you can have a good chance of knowing all the syscalls in your particular code, but what libraries are you invoking? What syscalls are they invoking? It quickly becomes in fact, this should probably be a topic for another LSS, is how to know what syscalls are called. But yes, in theory, you're correct. In practice, I've seen that bite people. So, but good question, thank you. Yeah, thank you, Eric, or some.
So I was just looking through some code. And,
fire away.
And I think what happens for us is that we have a whitelist typically for the initial filter. And then after some level of processing, then we actually have a deny list to basically scrub the things.
And that's totally legal. You can have multiple filters on a process, totally cool.
So I think that basically because we start with a whitelist, that we're always going to fail if there's a new system call. That's, that I'm just, in our particular use case, that's the way we do it. And to the other comment, I have to totally agree that our testing in pre-production is never good enough to find this, and we've gotten sniped more by syscall filters than we ever got sniped by SE Linux denials.
No, thank you. I agree. And like I alluded to earlier, one thing I have seen is if you've implemented your filter suboptimally and your testing is suboptimal, then those are the users that are reluctant to do upgrades because it makes their code not work, which suddenly exposes you to a whole nother can of worms. Tycho.
My understanding is that the default Docker filter a long time ago was implemented to return e-access instead of enosys. Like most user space knows, if I don't have this fancy new thing, I'll fall back using this old thing. And so like if you return enosys for most cases, like it should be fine.
Agreed. I think for the user that doesn't need the differentiation, setting their default to the enosys might just solve it for them. But that's not it. Unfortunately, that's not all of my users. But yeah, keep going.
Well, I guess my question is like, how much of this is just like people don't understand that they should really choose enosys instead of e-access? And like if you made that as a documentation change, does that fix this problem more than?
Case asked that a couple months ago, and I think that would probably be 90% of the users. But unfortunately, there's always this like these super duper power users who, for those you can't see, he's very hand waving, and I'm not going to argue. And that's one reason I brought this up, because in theory, this isn't a big change, but in practice, this is significantly changing the filter we're generating. And like I said, I really don't want to be here in 2 years with mea culpa, crud, sorry. I've just broken the world. So, yeah. One sec.
So I just wanted to add that there's one complicating factor there, that at least in some environments, there's a prescription that thou shalt kill. That's the only response we're allowed.
And I think that aligns with some users I've run into. For whatever reason, enosys does not meet the requirements they have, unfortunately. So, but no, I think back to what Tycho has said, I think updating our documentation to be more recommending of enosys might go a long way for many people.
The stuff that's bubbled up to me anyway is almost entirely Docker. And to me, that says there's a usability problem with Docker in the sense that you're running Docker and you upgrade a kernel and you upgrade glibc and you have nothing you can do
Correct.
to add any syscalls to the Docker filter.
Correct.
It's like 100% a usability problem with Docker that they need to fix.
Won't argue with that.
Yeah.
Yeah.
I just
Unfortunately, other people's bugs don't always, they don't always necessarily fall to.
And outside of that, enosys is the right solution unless you need to kill stuff. But again, it's how is the filter being created in the first place?
Correct.
And I think it's just a lot of really, really, really inflexible filter creation exists.
Well, and a question for you then, or for everyone. Is this a lack of education? Is like Tycho, is this, do I need to go out and evangelize more? How do I help them make a smarter, better, less crummy filter?
The system call interfaces are somewhat arbitrary and quite capricious. As a result, coming up with a global solution that's going to be rainbows and unicorns, it's just not going to happen.
Agreed.
And best effort documentation, best effort reasonable or explicable behavior is as good as you're going to get. It's like if as you say, we have OpenAT 42, which replaced OpenAT 41, and libc took it in, but libssl didn't. One of the problems I've always had with Seccomp is just that system call interfaces are a really bad place to go when you're talking about security, just because they aren't consistent.
Correct.
So I think anything that you do, so long as you shout it loudly, is probably going to be good enough.
Okay, thank you. The other thing too that I didn't bring up, libseccomp supports 20-odd architectures. They all do syscalls differently. I believe the kernel, I don't think there's any in the kernel that we don't support at present, but there may be, don't quote me on that. But either way, there's 20 plus architectures that are vastly and wildly different on their syscalls, so yet another monkey wrench in this whole thing. So, for the users out there of Seccomp and libseccomp, I glossed over the interface, but the interface we proposed we have what are called filter attributes, which let you specify how the filter behaves. So we've proposed extending that with 2 new enumerations. Does that meet your needs? We've not changed really effective the ABI or anything, just 2 new enumerations, and you specify the kernel version and the action to take. So I don't think that's scary, but tell me if it breaks. And of course, if no one here knows, anybody online, feel free to comment later. So. Thank you, by the way.
Stupid question, I guess.
Fire away.
Will you be warning when you load up a kernel and the filter is only supporting an older version? Because that would at least give pretty quick warning for somebody that actually looks at
A person could choose that. So to answer your question, no, libseccomp and seccomp in the kernel will not explicitly throw a warning. But if you wanted to make your action for any syscalls that are newer than you know about.
Well, I was thinking on load.
So
Because as soon as you load, you know that it's loading a version that is older than the one you're actually
we
running.
could add that to seccomp.
Yeah.
It'd be worth discussing. I'm hesitant to add warnings like that. Some users' warnings are immediately, oh, darn, my system's broken. And some users just throw them out the window. But I think that would be a good discussion that I would be open to. So, yeah.
Because that would at least give.
At least, yeah, agreed. Yeah. Maybe a verbosity mode or something where they get to. No, I think that's a good question. Thank you. Paul, or there's another one. Paul, did you have any comments as well or any thoughts? So, I mean, you don't have a mic just to warn you, so. But.
Thanks. Yeah, sorry, I'm a little gimpy, which is why I'm not standing up. But yeah, the only thing I'll say is, I mean, first off, thanks for everybody that's providing input. I mean, this was really kind of the motivation, and I would encourage you to go look at the PRs that are listed because Tom's put a lot of work in there, and it's basically we're kind of holding it because we want to make sure that we get the API right. Because that's at least from the libseccomp perspective, that's kind of the important thing because we don't want to keep changing the API on you guys because there are a lot of applications that use it. The other thing we think I'd want to stress is, and Tom's mentioned this a couple times, but this would be purely you'd have to opt into this approach, right? So if you're concerned about the implications of this and you just don't want to worry about it, like you don't have to use this functionality. You know, we talk about filter attributes, and for those of you who've never used them with libseccomp, that's something that you have to go in, and it's a way that we use it for a few different things, but it affects how the filter is generated. Like we talked about the default, actions for, if you're on a bad architecture or whatnot, those are all through filter attributes. So something like this would be through a filter attribute. So you don't have to worry, if you don't want to worry about this, you don't have to. It's just for those of you that do, want some help here. And like Thomas says, don't want to have to explicitly list out every single system call. This gives you a bit of shorthand to do that. So.
One other thing worth mentioning too, we take a very cautious approach to libseccomp code. We have 90+% code coverage numbers with automated tests over pretty much everything. So this, while not merged, is heavily tested and is an opt-in. So with all that said about me being afraid of being up here in 2 years talking about CVEs, I think it's a low likelihood. But nevertheless, I don't want to do that. Maxwell, did you have a question? Oh, one second, yeah.
More general curiosity than a directed question, but I was just wondering on a couple slides before this, from an assembly perspective, you have this, which is
this is pseudocode that we just. So it's obviously not. It's pseudocode we generate in our filter just to kind of be a human readable because it generates classic BPF, which probably many of you can read, but not all of us can. So anyway, keep going.
that more or less answers what I was worried about. I was like, I had not reviewed the PR. Yeah, I was going to ask generally about why you formatted the if statement like this.
Oh, yeah, no, it's, so to answer your question more explicitly, when you go to generate your filter, so we have this in-memory context we manage, and it manages all the relationships between the syscalls you explicitly chosen to handle, default actions, and obviously with this new stuff, actions for new syscalls. It's basically an in-memory database. Then when it's time to load it into the kernel, we generate a BPF. So literally the BPF instructions, and again, classic, not eBPF. If this, go there, if this, branch there. But we have another way to generate human readable. This is actually called pseudo filter code, or PFC, because we love three-letter acronyms here. But you can also generate the BPF and dump that out and view it human readably. So.
Well, so yeah, I guess my question is about the generated BPF bytecode, right? Which is when you generate the if check for the version comparison. So is that, are you inlining that into the filter effectively with the check on the syscall number, or are you doing a branch based upon the version number first and then having the subjects for
That's a good question. And I intentionally avoided implementation details but I'm glad to discuss this. So the way it's written right now, we have a gigantic table, and the table is two-dimensional. Architecture, syscall, and then version number added is in each cell. And so for a given syscall, open at 42, and ARM64 was added in 6.18, and x86 was added in 6.17, whatever. Based upon that information, then inside of the BPF filter, we can then generate the logic. And so the logic is this. The user specified, I want to allow open. So if the syscall being invoked equals open, 0 or whatever, if it equals read, write, whatever, 1, 2, allow it. Because I don't trust that I have a range, I'm saying then any syscall that hasn't been explicitly enumerated but I know about, I assign the default action. So for many filters, as Tycho pointed out, maybe E, allow, or whatever you've chosen, assign that to those. And then basically any number that is unknown at that point is a new syscall that's newer than our filter. That gets the E new, to new, whatever, which I'm recommending most people invoke E no sys. So to answer your question, I'm explicitly, every syscall known at that point has a number and an action given to it.
Okay, I need to look at the PRs.
Unfortunately, if we were really, really good about syscall numbering and we didn't care about older releases, we could say if it's newer than, if the syscall number is greater than the last one I know about, so for a lot of architectures, you're in the 400s now. If it's greater than that, do the enosys or whatever action is in that case. I'm leery of doing that. And in fact, that's what runc has done in their filter. With that said, it seems that theirs is working pretty well. Alexa hasn't complained. I reached out to him on the side, haven't heard anything. So it could be good enough. I'm just fearful if it won't be for those users that need more Department of Defense-y aviation type numbers. So thank you.
Thank you.
I mean, I guess the one that, this is kind of an obvious thing. I don't know why we didn't really talk about this, but I mean, we could support both.
100%.
I mean,
Yeah.
Right now we don't really allow, we don't have a mechanism or an API to say like, okay, if your syscall number is greater than whatever, but I mean, that's trivial to add. So
It'd be another filter attribute, as you well know. So.
Yeah, or that might actually be a real, I don't know, we can figure out the API, but
Well,
that would be tribute. That would be trivial. We could do both, really, I guess.
Maybe like there's strict or less strict or something.
Yeah.
Mm-hmm. No, I agree. That wouldn't be a horrible solution.
Is the performance benefit likely to be worth it?
So the question was, is the performance benefit likely to be worth it? The answer, it very well could be. So as written now, like I said, I am making an explicit BPF instruction for every single syscall. So for a particular architecture, that could be 400 instructions. We do have a binary tree in there, which should reduce the traversal down to 8-ish levels, but still, That's a fairly large filter, so you're stealing quite a bit of memory. So yes, it could be worth it.
And the compiler's not going to be doing nice things to help you with that, presumably.
No. In fact, we do our own BPF compiling in libseccomp, and there's only so much you can do with classic BPF anyway. If anyone's so inclined, you can talk to with Case afterward about converting it to eBPF. For those of you who can't see it, he thumbs downed it already. So, so yeah, I think I'm nearing the end of my time. Any last questions, thoughts, concerns? If not, I'll jump back to the end. I've linked the pull request here. Obviously, our main website's here. Feel free to reach out if you have questions. Feel free to reach out to me and or Paul on the side if you have questions. Thank you so much for your time.